Hi, Benjamin here. Welcome to our IoT Hangout. So today we have a guest, as we always have. So good morning, Ian. How about you introduce our guest?
Great, thank you, Benjamin. And I'm really excited to introduce Raghu Sudhaka. I was pronouncing his, hopefully I pronounced the last name. I was practicing beforehand, from CISCO, and also Raghu is actually the project leader of Cricut. And actually, I had an opportunity to have lunch with Raghu last week, and we're chatting about Cisco's fog computing strategy and data in motion and Cricut, and I think it's a fascinating story that Cisco's putting together. So I wanted to bring him on today and share with people. So Raghu, welcome to our hangout. It's
Thanks, Ian. Thanks,
yeah,
Benjamin.
we have
Nice to meet you.
we have high aspirations that this is going to be like a huge media channel eventually and a big show. But right now it's probably just the three of us listening. But people do watch the reruns, the views, right? So Raghu, why don't we start with so Cisco has come out with this term fog computing. What does Cisco mean by fog computing?
So everyone's very familiar with what cloud computing is, right? You have data that's being generated at the sources, and the data is all being transported over huge pipes, and you do the computation at the cloud. So by computation, you mean you do the data mining, data analysis, and a whole bunch of other things that people do.
Right.
Now, when making the transition from this legacy networking thought process to IoT, where you're connecting every device, any small devices, large devices, you have hundreds of devices within a house. When you want all of these devices to generate data and make sense of the data, the pipes are no longer as useful as before to take the data back to the cloud and do the computing and bring you useful results, right?
It's basically just going to be overwhelmed, right? The network's going to become overwhelmed.
Right. You're going to have a lot of latency issues and a whole bunch of other things, right? Or rather, let me put it, to say it in a concise way, the relevancy of the data is lost. If we take all the data to the cloud, do the processing, and then try to do some meaningful actions based on what the data means to us, right? So the general consensus is that the computation or the capability to process this data needs to move out to the edge, closer to the sources of the data. And the vision by which this can be achieved, moving the computation out to the edge, moving it closer to the data sources, and in a hierarchical way, like the computes right out at the edge are doing some basic computation, and then they're passing it on to the next level of the hierarchy, which does some more computation and so forth. So by the time the data reaches to the cloud, typically you're doing something that's of archival nature or something that's extremely domain specific, and the latency is not that important. So this entire vision of building this hierarchical compute mechanism is what fog computing is all about. So it's this grandiose vision on how this can be achieved in the long term, and definitely there are tremendous benefits in doing so.
Yeah, well, and I think kind of when I heard, to me, the data is going to be so important for IoT, and there's going to be so much of it, and I've yet to find someone that's really thinking through kind of a different way of handling all this data, right? If we use the old traditional ways, like even the big data vendors, like they kind of aren't seeing. I don't see, and maybe I'm just missing. I don't see a lot of innovative thinking in this area about kind of how do you handle such huge amounts of data.
Right. So the legacy thought process is typically store first and analyze later, right? So what we've been doing is take all of this data, throw it in a data store in a database, and then you can start running your algorithms and data mining algorithms and whatever else you want, right? But what we're trying to do within Cisco to achieve this fog computing vision and actually address the real problems of IoT, which is the large volumes of data and the large variety of data, is flipping this thought process on its head. We want to analyze first and store later only if it's relevant, right? So by analyzing, what's the rationale behind this? The rationale is that we um,
Do you want to deal with your guest? Do you want to deal with your guest
Yeah.
that just came in?
Yeah, just give me a minute. Just give me a
Okay,
minute.
go for it. Go for it. Yeah.
Vijay.
You know, on live TV, you have to deal with things like this, right, Benjamin?
Yep.
So should we talk about the weather now?
Yeah. So yeah, the weather in truth is great, right?
Actually, in Ottawa, it's going to be 29 tomorrow, so 20 Celsius too for our
yeah,
American
I was
friends.
wondering. Okay, Celsius, that's fine. All right.
So if anyone is listening, if you have questions, we would love to have a question. You would be the first question ever. So, Gregory, you're back.
Yeah, sorry guys, sorry for that.
No problem, no problem. Live TV, we're on, right?
Yeah. So yeah, what was I saying? Yeah. So we want to flip this on its head, and we want to analyze first and store later. And the reason why we want to do this is if you go back and look at the data, right? The data that's being thrown into the data stores, it's actually a whole bunch of known data, data that is not very relevant to us. For example, sensor data, right? Sensor data is typically the same all through the day, right? There's going to be a few events at 3 p.m. in the day, the door opened, or something weird happened, and that's what you want to know. And what happens more often than not in the current situation today is when you're running a data mining, you're scrubbing the data for all of these known values, right? What you're typically looking for is peaks, ramps, and some kind of patterns in the data.
Right.
So now if you're able to analyze the data for these patterns right at the source, right at the time that they're being generated, and store only those patterns, what you're effectively doing is feeding improving the quality of data that you're feeding these machine learning algorithms, the data mining algorithms, and hence they can provide better output. You're reducing the amount of storage that is required. You're reducing the amount of network bandwidth that is required to take all of this data back to the cloud, right? So there's advantages in a whole range of different avenues,
Dimensions,
right?
Yeah. And so is this kind of where you guys start to talk about data in motion?
Right. So this this method of analyze first and store later is what data in motion is all about. So to put it in a nutshell, data in motion is a line rate indexer. Okay. So as the data is flowing through our network, as the data is flowing through the routers and switches and all of those other devices that are sitting in the network, what we want to do is we want to index the data and transform it into a domain where it is searchable, right? So by allowing the search capability on the data right when it is being produced, right when it is being generated, what we're able to do is we're able to analyze for those patterns that we're interested in. So, for example, if you consider a healthcare situation, right? Say a heart monitor for a patient who has some issues, and almost all the time it's okay. But then there's this one situation at 3 p.m. in the morning where there's an event. The machine starts beeping and stuff. Right now, what actually happens is there is a physical sound that's being generated, a beep, and that is what gets the nurse from her station to come and look at the person. But what we could potentially do is, by having the indexing and the search capabilities right at the edge, we could capture that event and now pass that event on to a whole bunch of other endpoints, and all of this could be done automatically and in near real time. Probably even faster than the nurse would be able to pick up a phone and call the doctor and whatever else, right?
Right.
And this is definitely not possible in the current situation where all the data needs to be thrown in a data store, then you run some analytics on top of it, and it's already the data is going to be 5 or probably even 10 minutes delayed, and you've lost that amount of time. So by flipping the store first and analyze later to analyze first and store later, we are achieving what people have been thinking about for a long time as what IoT should be able to do. Right? When you're connecting your devices, when you're connecting all your devices to the network, what you really want to see is those devices generating data or doing something meaningful that impacts human life in an effective way. Right? and that is what this is one small step towards that.
Sure, sure. So let's bring in Cricut here. So Cricut is an Eclipse project that your first code contribution came in this week. Congratulations. So why don't we let's talk a bit about kind of how Cricut helps with the data in motion vision that you've laid out.
So now we have this nice technology where we're able to index at line rate, and we're able to transform the data that can be searched, right? Now, we need a mechanism by which this capability can be exposed to the end user, right? Say a user who wants to write a home security application or a healthcare application, or in an industrial scenario, some kind of an automation for the assembly line. So we need to expose the capability of searching through the data right when it's getting generated to the user. And we need a very nice set of APIs or language that the user can use to program data in motion, to program data in motion to look for certain events or whatever is of interest to the user, right? And this is what Cricut is all about. Cricut is the set of APIs that sit on top of data in motion and expose the features of data in motion to the end users. And typically, the end users are going to be the people who are going to who are domain experts and who are going to be developing business intelligence, as is well known to the community.
Yeah. So when you say end user, it's more the developers. Like it's kind of the people building the end user applications.
Exactly. That's correct. The user.
It's not the nurse. It's not the nurse.
Absolutely, yes. Right. It's definitely not the nurse. The nurse is going to use the application, and the developer who makes that application is going to use data in motion and Cricut together. Right. So that's the entire stack, one on top of the other. And we're thinking of Cricut in a much larger scale, in the sense that it is not just restricted to data in motion, but any kind of rules engine, any kind of event detection system that you might have for IoT in general, right? Shortly, we will also be releasing a non-data in motion rules engine or an event detection engine that people can put on their Arduinos or Raspberry Pis and use Cricut in conjunction with that piece of software, right? And that could potentially also be open source. And it's an example of how this whole thing stacks up, right? You detect the events at the edge, and you have a layer on top that's searching through the events right at the edge, and then you do your business intelligence.
Yeah. So basically, the kind of CISCO will have a commercial product called Data in Motion or something like that. But if someone wanted to take the same API and use it for a Raspberry Pi or some other even commercial hardware, they're going to be able to do it with Cricut and a rules engine that you guys are going to put together for the open source.
Absolutely, yes. Or they could write their own rules engine that just implements the Cricut API, right?
Yeah. So basically, an application built using this API can scale up to kind of a small prototype using a Raspberry Pi or a kind of a huge but huge, very large-scale application using a CISCO device that has a lot of scalability and reliability put in.
Absolutely, yes.
Cool. This sounds great.
Yeah, I've seen the so yeah, as Ian said, the code contribution is coming, and I've seen that you have a couple of sample codes and demos. What one could do with Cricut? What are the typical examples that you use when you demo Cricut?
So the typical example we use is in conjunction with sensors. Take, for example, the home automation use case, right? That's the easiest one to do for us, and that's what we mostly do. And that's going to be at the CISCO Live Hackathon also. And we have a couple of Arduinos, Raspberry Pis. All of these are collecting different information, accelerometer information, light meter information, and whatever else, right? And we want to write, we want to detect the event where the light sensor is above a particular value and the accelerometer is above a particular value, right? Now, typically the way people would do this is write some custom piece of code on the Raspberry Pi that's specific to the Raspberry Pi and try to detect that event. And that is how all home automation systems as of today have been doing it, right? All commercial off-the-shelf products are doing exactly that. So with Crikkit and the other piece of code that we will be shortly releasing that can run on the Raspberry Pi, we could actually make that entire thing dynamic in the sense that you don't need to deploy code on the Raspberry Pi or on the sensors every time, but all you need to do is program the data in motion engine that's sitting at probably the gateway of all of the sensors with the new rules, and you can pick up those events on the fly, right? And you can change them whenever you require. You can start programming in in what we call the event space, right? So instead of going down to the data and collecting the data, converting it, and making doing some kind of thresholding activity or whatever you want to do with it, you have all of that taken care of by the rules engine or the event detection engine, and then you program the event detection engine using Cricut.
Okay, great. Okay.
We actually have a question.
Sure.
From the audience. So this is the first. So Raghu, congratulations. You're right. So and it's from Toby, who's a good friend, Toby Jaffe. So surely in many cases we want to build dumb sensors and deploy them under concrete. Here we don't know what to analyze for in advance. How does Cricut deal with that?
Yes. So very good question, and we did think about it the same way. In fact, the example that I gave when we were doing the design for this was exactly the same. What happens to sensors that go in concrete and cannot be changed for their lifetime? Okay. That's kind of coincidental. Yeah, yeah. But with Cricut, what we're introducing is what we call a data model. Okay. So typically, all of these sensors are generating binary data, right? And obviously, you know what the data format is. Like, for example, a sensor is generating a 4-byte integer every 5 seconds, right? And those 4 bytes come to you as binary. Now, we have this concept of a data model in Cricut that can convert that binary information into an integer, into all of the native data types, right? Integer, character, and whatever else. And that subset is growing with respect to the data types. And now once it's converted to a native data type, then the rules engine or the event detection engine can perform the thresholding activities or whatever other logic that you want on top of it. So that's the way we want to, we're planning to deal with the problem of the large number and variety of sensors and sensors that are generating different payload formats, right? So you apply a data model to the payload, so that the data model converts the binary data to native data types, and then you do your computation on top. So that's the progression, or the way you would deal with that.
Cool. Okay. Sounds great. So, go ahead.
In a sense, what we're trying to avoid is being stuck with particular vendors or particular device types, right? And we don't need to have a central database of like a repository of all the payload formats. For example, you Ian could choose to interpret the data in a different way as two 16-bit integers, and I could interpret it as a 32-bit integer. So that's the kind of flexibility that we need, and we want to allow through Cricut.
Yeah, perfect. So I think a couple of just kind of for the community, I think the Cricut mailing list should be getting up and going soon. So follow-on questions probably we could encourage people to ask those on the Cricut mailing list. There's and Raghu, you mentioned it, there's CISCO has a big conference next week in Moscone in San Francisco, and there's a hackathon starting May 20th that includes Cricut. So if you want to go and hack on, and Cricut is actually a set of Java APIs for now. I think you're going to have a CC++.
Yes, we have both. We have both.
Yeah. Okay.
And both have been open source.
Okay. And so put a link to the hackathon on the event page so people can see it there. But Raghu, this is I really think you guys have thought this through quite carefully, and it's fascinating. So I'm looking forward to seeing the participation in Cricut and building up that community. So so we're going to switch briefly just to kind of some other IoT industry news now. So Benjamin, why don't you go first? What have you seen interesting this week?
I don't have much actually. The only thing I maybe wanted to show, I could just quickly share my screen here. We've been discussing that on Twitter, right? We see so many Kickstarter projects and the like, and this is the Taily. So I don't know if you guys have seen, but it's basically as it says, a tail that wags when you get excited, right? So it's a connected tail, and the fun part about that is that the guy who actually put together this product, I don't even know if it's a real product, but it's also the guy who invented the Rapier robot. You may remember about this robot. We've talked about it, I think, during the previous hangout. Yep. So yeah, we see so many of these projects, right? And it's not sure where.
I want to know if it's real. I want to know if it's real. So supposedly they put sensors on a belt, right? That tracks your heart rate, and as you get excited, your heart rate goes up and your tail wags faster. So I'm not going to buy it, but yeah, I'm pretty sure it's a spoof. I hope it's a spoof. Let's put it that way. So for me, I think that the one thing that I found interesting is Information Week did an article, which I think was one of the best articles I've seen on IoT, talking about the challenges of IoT. And they went and interviewed some large companies, some the kind of GE type companies, and they identified kind of 5 key things that are holding back IoT. And so Benjamin, we'll put a link to the article in the not in the chat, but in the event page. But things like
the main issues was the security, right? It's what most people talk about, right?
Security and also data. So actually, I did a response to that article in a blog post, so we'll link to that too. But in the blog post, I talked about Cricut too. That kind of we need to get smarter about handling this data. And so I thought it was a really interesting article and it made me think that what we're doing at Eclipse IoT is going in the right direction, that we're actually solving some of the real issues out there for people putting together IoT solutions. So, I think why don't we call it a wrap? And unless you have anything else, Benjamin? I think why don't you just talk about the unconference at EclipseCon France, just quickly?
Yeah, there are a couple IoT events coming, and one of them is obviously EclipseCon France. So it's on June 18th and 19th in Toulouse. So of course you can still register for the conference. We have 6 or 7 talks around IoT protocols, device management, JavaScript on microcontrollers and stuff like that. And on the Tuesday before the conference, on the 17th, we organize an unconference. So the idea is that we have a room, basically, and we hack. So we will have Eclipse OM2M. I'm pretty sure we will have Co-op and Wakayama, Eclipse Californium and Eclipse Wakayama. So yeah, we will have hardware, we will have the project leads, and so yeah, you're very welcome to join. And if you have projects you want to put together, new features you would like to help get implemented in the project, this is definitely something you need to attend. So you basically go to eclipsecon.org/France 2014, and from there you get all the information to register, and it would be. I mean, yesterday, actually, we were discussing earlier, Ian, we had our first meetup in Toulouse, and so I know there's already a great IoT crowd in Toulouse. There is definitely a great crowd in France and in Europe also. So, absolutely. Yeah, I'm sure we will have, it will be a great event. Looking forward to it.
And Toulouse is always a beautiful place to visit in June.
Yes.
Sure.
All right. Well, I think what's called a wrap. Raghu, thank you very much. And I'm looking forward. I'm going to actually try and attend some of the hackathon next week, and I'm going to be in San Francisco actually for the O'Reilly Solid conference. I'm going to be there, and I'm definitely going to make it over to the hackathon. So thank you for joining us,
Ian, and thanks for having me. Thanks, Benjamin.
Thanks, Raghu.
Okay, take care.
Bye bye.
Okay.